If the theoretical yield for carbon dioxide is 88 grams, so theoretical yield is 88 grams, and the mass of the carbon dioxide obtained in the lab is measured to be 80 grams, what is the percent yield? So when you're thinking about percent yield, you need to know two things. You need to know your actual yield, and you need to know your theoretical yield. And your actual yield can only come from the experiment. So let's go back and see which one of these is the actual yield and which one is the theoretical yield, so we can start writing these things down. If the theoretical yield for carbon dioxide is 88 grams, so they said that the theoretical yield is 88 grams, and the mass of carbon dioxide obtained in the lab is measured to be 80 grams, so since it's from the lab, that tells me, oh, that was the actual yield. What is the percent yield? So we actually have all the information we need to calculate percent yield. We actually didn't need to do a calculation here to find theoretical yield because that was just given to me in the problem. So remember that percent yield is equal to the actual over the theoretical times 100. So this problem's super easy because all we got to do is 80 divided by 88. So I did my actual yield divided by my theoretical yield times 100. So we got 80 divided by 88. Did I just write plus? I just wrote plus. 80 divided by 88 times 100. And so that would be 90.9. So I'll round that up to 91% yield. So that problem was super simple because we were given an actual and theoretical yield. So we didn't need to calculate our theoretical yield. We could just plug into our percent yield equation. Let's take a look at number 2. If a chemist begins with 86 grams of C3H8 and 1,000 grams of oxygen gas, how many grams of water will be theoretically produced? If the chemist's actual yield is 120 grams of water, so we know this, what is the percent yield? So what we're trying to figure out here is how many grams of water would theoretically be produced. So this time we were not given our theoretical yield. We have to figure it out. If you look at our equation, we're trying to figure out how much water, H2O, is going to be theoretically produced. And we're beginning with 88 grams of C2H4 and 1,000 grams of oxygen gas. So if we want to figure out how much water we're going to make, we need to start with our limiting reactant and do one of those 4-step stoichiometry problems that we should be so familiar with at this point. Because I have so much more oxygen than I have C2H4, I'm going to assume, I don't even really need to calculate this. I know this is going to be excess, and I know this is going to be limiting just because I have so much less of it. Now, I know in the last lesson, we actually calculated to figure out which was limiting, but because of the huge difference in the amounts, the magnitudes, and just looking at this equation, I know that I'm going to have a ton extra oxygen, that I know that that's going to be excess. So what I'm going to do is I'm going to start writing what I know, which is I know I have 88 grams of C3H8. So I start with my limiting reactant to figure out how much product I could theoretically make. And I'm trying to go to grams of H2O. So I'm writing grams of H2O at the end because I know I have to end in that. As you guys should know by now, my next step is to cancel my grams of C3H8 and go into moles of C3H8. And I put my molar mass of C3H8 at the bottom here. And I'll fill that in a moment. Then I don't want to be in moles of C3H8. I want to be in moles of H2O because that's what I'm looking for. So here's where I put my molar ratio. So I go back to my equation. In front of H2O is a 4, and in front of C3H8 is nothing. So I assume a 1. So I have 4 for H2O over 1. Finally, at the end, I don't want to end in moles of H2O. I want to end in grams. So I'm going to cancel my moles of H2O, and I'm going to put the molar mass of water in here. So I'm looking at my periodic table, and I'm looking at carbon and hydrogen and oxygen. So I can figure out my molar masses of these two things. So carbon was 12 grams times the 3 carbons in C3H8 for 36. H is 1 gram times the 8 hydrogens. So that is 44. H2O, H is 1 gram times 2 H's in H2O. O is 16 grams times 1 O in H2O for a total of 18. Now I multiply everything in my numerator. 88 times 1 times 4 times 18. And I write that number down. And in my denominator, I have 44 times 1 times 1, which is 44. So now I'm going to divide 6,336 divided by 44. $144 grams of H2O. So that's my theoretical yield. That's theoretically how many grams of H2O I could make. Let's go back to our problem here. They said that the actual yield was 120 grams. So what I need to do now is I need to find my percent yield. So percent yield is the actual, which was 120, divided by the theoretical, 144, times 100. So I'm going to do 120 divided by 144 times 100, and I get 83% yield. This is our final guided practice problem for today. If a chemist begins with 88 grams of C3H8, that's what I know, how many grams of carbon dioxide will be theoretically produced? If the amount of carbon dioxide obtained in the lab is 200 grams, what is the percent yield? So if the amount of carbon dioxide obtained in the lab, so that's my actual yield. So I'm just going to write that over here. And we're looking for our theoretical yield. And we find that by doing a stoichiometry problem based off the starting amount. Since I'm only given one starting amount, I don't need to worry about limiting reactants. I just start with that one starting amount. So I did my 4 steps for a gram to gram conversion to figure out how many grams of carbon dioxide will be theoretically produced. So carbon dioxide is CO2. So at the end, I'm going to put my grams of CO2. That's what I'm going to be looking for. And I'm starting with 88 grams of C3H8. So again, I'm going to cancel my grams of C3H8, and I'm going to get into moles of C3H8. Then I do my molar ratio between what I'm starting with and what I'm trying to find. Moles of C3H8 to moles of CO2. So I go back to my equation. CH3H8 has a 1 coefficient because nothing's written. CO2 has a 3. So that would be 3 over 1. And then at the very end, I'm going to find my molar mass of CO2. So that I will end in grams of CO2. So let's go ahead and fill in these molar masses. C3H8, we already found from the last problem, was 44 grams. And CO2 is, C is 12 times 1. O is 16 times 2. So that would be 32. So it's also 44 grams. So that's just a coincidence that they have the same molar mass. So we have 88 times 3 times 44 in our numerator. So that's 11616. And then divided by just 44. And so that's 264 grams. So that's my theoretical yield. And this was my actual yield. So again, to find the percent yield, we're going to do the actual yield, 200, divided by the theoretical yield, 264, times 100. It's kind of getting crowded here. Sorry about that. So we got 200 divided by 264 times 100. So a 75.75. So 76%, oh my gosh, percent yield. The only problem I want you guys to do before your exit ticket today is this top problem, number 1, on page 24. So finish this problem. You're going to take a picture of that finished problem, and then you're going to do your exit ticket. Then tomorrow you guys should be finishing the rest of the problems on pages 24 and 25.